NumPy is a fundamental library for scientific computing in Python, providing support for arrays and matrices along with a collection of mathematical functions to operate on them efficiently. NumPy arrays are the core of the NumPy library. They are similar to Python lists, but they come with added benefits such as efficiency, functionality, and dimensionality. Understanding how to create and manipulate NumPy arrays is foundational for scientific computing and data analysis in Python. Before we start, we are going to need to import the NumPy library. So to do that, we will do import NumPy as np. It's common practice to import NumPy using the alias np, which makes it easier to reference the library's functions. One of the simplest ways to create a NumPy array is from a Python list or tuple using the np.array function. A one-dimensional array, also known as a vector, can be created by passing a list or a tuple of numbers to the np.array. This array will act similarly to a list, but with additional functionalities provided by NumPy. To create the one-dimensional array, we will start by creating our array variable. It's going to be called array1d, and we'll use the NumPy function np.array to create our array. And here we'll pass in a basic list of 5 numbers. And if we want to take a look at our 1D array, we get our array that we have created. By creating this array, we will be able to perform various mathematical operations on this array, such as addition, subtraction, and other element-wise multiplication operations. To create a two-dimensional array, or matrix, you can pass a list of lists, or tuples of tuples, to the np.array function. Each inner list represents a row in the matrix. So let's create our new array. This time it's going to be array 2D for two-dimensional. And we're going to use the np.array function again. And here we're going to provide a list of lists. And we're going to have one list, and inside we're going to have 2 lists, where each list represents one row. And so we'll have 1, 2, 3 here, and 4, 5, 6. And let's take a look at our array. And when we run that, we have our 2D array. And this has created a 2x3 matrix with 2 rows and 3 columns. This structure allows you to perform operations like matrix multiplication and transposition. NumPy also supports arrays with more than 2 dimensions, known as multi-dimensional arrays or tensors. You can create these by nesting lists or tuples even further. To create our 3D array, we're going to create our new array, and this time with 3D. And again, we're using the np.array function. And here we're going to first provide one list. And then within that list, we have 2 lists. And within each of those 2 lists, we have another pair of lists. So we are going 3 levels deep. We have a list, which has a list, which has a list. So 3 level of lists. And so we are going to add a decimal point here, but here we are going to add our values. So it's going to be 1 and 2. And this one is going to be 3 and 4. Here it's going to be 5 and 6. And here it's going to be 7 and 8. And when we take a look at our array, which is 3D, we have our 3-dimensional array. And here we have the dimensions of 2 by 2 by 2. So this kind of array is useful in advanced computations like those found in machine learning and scientific simulations. So we have, like I said before, it's sometimes hard to visualize, but structuring it might kind of help to visualize it. So like I said before, we have our first level, which is our one list. And inside that first list, we have the two blue lists. And within each blue list, we have another two lists, which are going to be yellow. NumPy arrays come with several attributes that provide information about the array structure and data. Understanding these attributes can help you to manipulate arrays more effectively. So let's take a look at some of these attributes using our 3D array. So once again, let's take a look at our 3D array just for some reference. And to find out the number of dimensions of an array, we could use the ndim attribute. So array3d.ndim, and when we run this, we see it is indeed 3 dimensions. So like I've said before that this array was a 3D array, this confirms that this indeed is a 3-dimensional array. Now if we want to find out the shape of an array, which is basically a tuple indicating the size of the array in each dimensions, we would use the shape attribute. So again, we use array3d.shape, and when we run that, we have indeed 2 by 2 by 2. So that is the shape of the entire array. If we want to find the total number of elements in the array, we would use the size attribute. So we could change this to size, run that, and we have 8. So that basically tells us how many total elements we have in our array. So here we have 4, we have another 4. So again, that's a total of 8. And if we want to find out the data type of the array's elements, which are inside this array, we would use the dtype attribute. And when we run that, we see that we have of type int64. So these are basically int values inside our array. NumPy provides several functions to create arrays with specific patterns or values, which can be highly efficient for initializing arrays without manually specifying each element. To create an array filled entirely with zeros, you can use the np.zeros function. This is often used as a starting point in algorithms where you need a placeholder array. So if we want to create a 1D or one-dimensional array filled with zeros, and specifically we want 5 elements of zeros, we could use the zeros function. So we are going to be creating the zeros one-dimensional array variable, and then we use np.zeros, and here we would specify how many elements we want, and that would be 5. And then when we run zeros 1D, we can see that we have indeed an array of 5 zeros. If we want to create a 2-dimensional array, we would have to provide a tuple with the number of rows and columns. So here again, we would do zeros, this time 2D for 2-dimensional, and np.zeros, and instead of providing one value, we will provide 2, and in a tuple form, so it will be rows comma columns, so 3 rows and 4 columns. And if we want to take a look at zeros 2D again, we have 3 rows, 1, 2, 3, and 4 columns. Similarly, you can create an array filled with ones using the np.ones function. This is useful in situations where you need an array initialized with ones, such as in certain normalization processes. So again, very similar to zeros, we'll create our ones 1D array, and we will use np.ones, and when we provide 5, and then we will take a look at the ones 1D, it provided 5 ones in one array. And similarly, if we wanted to create a 2D array filled with ones, then we would do np.ones, and then again, using some kind of tuple, we would provide the rows and columns. And if we want to take a look at the 2D dimension again, we have again 2 rows and 3 columns of ones. If you need an array filled with a specific constant value, you can use the np.full function. This is particularly handy when a particular value is required for initialization. So if we want to create another 2D array but filled with 7s, then we would create our constant array, and we use the np.full function, and here we provide the dimensions of our array. So let's say it's going to be 3 by 3, and then we provide the value that we want it to be filled with. So let's say it's going to be 7, and if we take a look at our constant array, it is a 3 by 3 filled with 7s. Identity matrices are square matrices with 1s on the main diagonal and 0s everywhere else. Numpy provides 2 functions to create such matrices. The first one is the np.identity, which creates a n by n identity matrix where we provide the dimension that we want to create. So to do that, we will use the np.identity. And if we want a dimension, let's say 3 by 3 or 4 by 4, then we would just provide the number 4. And when we run this, we have a 4 by 4 matrix where 1s are on the diagonal and 0s are everywhere else. Similarly, we could use the second option, which is the eye function. So instead of identity, we could use the eye function, where 4 is going to be again, the dimension of the matrix. And when we run this again, it of course shows us the exact same matrix. You can also multiply the identity matrix, so the matrix with the 1s across the diagonal, by a scalar or a constant number to adjust the values along the diagonal. So if we multiply this by 5, we will get 5 across the diagonal instead of 1s. Numpy offers functions to create arrays with sequences of numbers, which is useful for generating indices or ranges of values for calculations. The np.arrange function creates an array with evenly spaced values within a specified interval. It works similarly to Python's built-in range function, but returns a NumPy array. So let's say we want to create an array with the values from 0 to 9. So let's create our range array, and we will use the np.arrange function, and we'll provide 10 because we want 10 values from 0 to 9. And when we show that range array, we have exactly that, values from 0 to 9. If we want to create with the values from 5 to 50, but with steps of 5, so it increments every 5, so 5, 10, 15, 20, and so on, we would change this just slightly a little bit. First, we provide the starting value, then the ending value, and then the steps, so incrementing by how much, it will be 5. And then when we run this, we have exactly that. And so this creates this array from 5 all the way to 50. So again, the 55 represents that it stops at 55, therefore it does not include it as part of the values. The np.linspace function generates a specified number of evenly spaced values over a given interval. This is particularly useful in scientific computations where you need to sample a function at evenly spaced points. Let's say we want to generate 5 numbers between 0 and 1. To do that, we will create our linspace array, and we'll use the np.linspace space, and here we'll provide the values. So the interval in which we want the values to be generated and the number of values that we want, which is going to be 5. And if we take a look at our linspace array, it generated exactly that, so 5 different numbers between the values of 0 and 1. If we wanted to generate 10 numbers between 0 and 100, then we would change this from 0 to 100 and change this to 10 for 10 numbers. And then when we run this, we have 10 different numbers. So the linspace function creates an array of numbers that are evenly spaced between the set intervals. Numpy's random module allows you to generate arrays with random numbers, which can be useful for simultaneous random sampling and initializing algorithms. To generate a 1D array of 5 random floats between 0 and 1, we would use the np.random.rand function. So np.random.rand, and then how many numbers that we want to be generated. We want 5, so we provide that. And then when we run that, we have 5 randomly generated numbers between 0 and 1. If we want a 2D array, then we would have to change this and provide 2 values. So 3 by 4, for example. So 3 rows and 4 columns. And then we run that. We have exactly that, 3 rows and 4 columns of random numbers between 0 and 1. If we want to create an array where we generate random numbers between specific numbers, and so instead of 0 and 1, then we would use the randint function. So we would change this to randint. Then we'll provide the intervals of the numbers that we want to generate between. So let's say we want 10 and 50. And then how many numbers we want to generate. So let's say we want 5. And that generates a 1D array with random numbers generated between those intervals between 10 and 50. Now, each time you run these functions, they produce different random values. If you need reproducible results, you can set the random seed using the np.random.seed function. So if we take a look at this and we run it multiple times, we see that we're gaining different values each time that we run it. And if we want to get the same results each time, then we need to set the seed. So for example, let's do np.random.seed, and let's provide a seed of 42. And when we run this again, we have this set of values. And if we keep running this, we're always going to get the same set of values. By setting the seed, you ensure that the random numbers generated are the same every time you run the code, which is essential for debugging and consistent results in experiments. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.